Hello everyone, in this video we'll discuss about the implementation of queue data structure using array in C++. A queue is a linear data structure that follow first in first out principle. It operates like a line where elements are added at one end, that is a rear end, and removed from the other end called the front end. For example, people waiting in line for a rail ticket form a queue. Insertion can take place at rear end and deletion can take place at front end. If we want to insert element into the queue, then rear is equal to rear plus 1. And if we want to remove element from the queue, then front is equal to front plus 1. There are 5 basic operations performed on a queue. In queue means to add an element to the rear of the queue. And dequeue means to remove and return the element from the front of the queue. And peek operation return the element at the front of the queue without removing it. And isEmpty function check if queue is empty. And isFull function check if queue is full. Let's see the program code for the array representation of a queue. In this code, queue is the name of the array and size of this array is 5. And the front variable points to the position of the first element of the queue. In C++, when we use an array to implement a queue, the front variable will store the index of the first element of the queue. And it is initialized with the value of -1 as the queue is empty initially. Just like we need a front variable for the deletion operation, we would also need a variable that points to the back of the queue so that we know where the new element needs to be inserted in case of an insertion operation, as new elements are inserted at the back of the queue. The rear variable points to the position of the last element of the queue. In C++, when we use an array to implement a queue, the rear variable will store the index of the last element of the queue. It is also initialized with the value of -1. That means queue is empty initially. Then define the peek function to return the element in the front of the queue. If front is equal to -1, we can say if the queue is empty. Then with cout display the message the queue does not have any element. Otherwise, printing the front element of the queue with cout, the element in the front of the queue is queue of front. Then define the isEmpty function to check if the queue is empty. Bool is the function return type, isEmpty is the name of the function. If both front and rear are -1, then queue is empty. Then this function return true. Otherwise, this function return false. When we want to perform a deletion operation, we can check first if the queue is empty and perform the operation only if the queue has an element. Then define isFull function. Bool is a function return type, isFull is the name of the function. This function check if the queue is at full capacity. When we want to perform an insertion operation, we can check first if the queue is full and perform the operation only if the queue has space for additional elements. If rear is equal to size -1, That means if the rear variable is equal to size minus 1, then the queue is full. This function return true. Otherwise, this function return false. Then define the function to get the number of items in the queue. Int is the return type and size is the name of the function. Inside the body of a function, first of all check if the queue is empty. If this condition is true, then this function returns 0. Otherwise, the number of items in the queue is the difference between front and rear. Then define the inQueue function. This function is used to insert a new element into the queue. The queue follows first in first out order. Any new element which is to be inserted should be inserted at end of a queue. To insert a new element at the end of a queue, we make use of the rear pointer. Inside the body of inQueue function, first of all check the condition. If is full is equal to true. If the queue is full, then we cannot push a new element. We return that the overflow condition has been encountered. Otherwise, we push the new element. If front is equal to minus 1, that means we add the first element in the queue and update front. If front is equal to minus 1, then front become 0. Then we update the rear pointing to the last element of the queue, that is rear plus plus. Insert the element into the rear position. Queue of rear is equal to val. Then with the help of cout, display the message. Value was inQueued pushed in the queue. Now in queue function, we also need to check if the queue is at its full capacity. If not, then we insert a new element at end of a queue and update the rear variable to point to the new end of the queue, which is the element we just inserted. In case this is the first element is inserted, we also need to set the front value to 0. Then define the dequeue function. This function is used to delete a data element from the queue. The queue follows first in first out order. If we want to delete an element, it has to be the first element of the queue. To delete a data element from the front of the queue, we make use of front pointer. Inside the body of a function, first of all check if the queue was empty. We cannot pop any element out of it. If is empty is equal to true, then underflow condition encountered, this message is to be printed onto the screen. Otherwise, we pop the element in the front, that is print the popped element. Dequeued pop queue of front and increase the index of front plus plus. Now front points to the second element in the queue. Then resetting the queue when the last item is popped from the queue. If front is greater than rear, then front is equal to rear is equal to minus 1. We can say assigning both the front and rear to minus 1. Then after that, define the display function to print the elements in the queue. If rear is equal to 1, that means queue is already empty. There is no element in the queue. Otherwise, declare a variable I that help in iteration through the queue, and with cout display the message printing the queue. And for I is equal to front, loop start with front and I is less than equal to rear. If this condition is true, then queue of I element at first index is to be printed onto the screen. Inside the main function, first of all check the if condition, checking if the queue is empty. If queue is empty, then display the message queue is empty. Otherwise, assigning elements to the queue. First of all, in queue 1, we add 1 to the queue. As this is the first element, we update front is equal to 0. Then increment rear so that rear is 0. And then assign queue of rear is equal to 1. Then after that, again call the inqueue function, inqueue 28. Now we add 28 to the queue. We first increment rear so that rear become 1 and assign queue of rear is equal to 28. Then in queue 5, again insert element into the queue. Rear is equal to rear plus 1. In queue 64, again insert the element 64 into the queue. Rear is equal to rear plus 1. Then call the peek function. Peek function print the first element of the queue. Then output is 1. After that, call the size function. Size function display the size of a queue. Now in this case, size of queue is 4. Then call the display function. Display function display all the inserted element into the queue. The output is 1, 28, 5 and 64. Then call the dequeue function. Dequeue function popping the element from the queue. If we want to delete the element from the queue, then there is a front end. Front is equal to front plus 1. Element 1 is deleted from the queue. Then again call the dequeue function. The element at front index is 28. 28 is deleted from the queue. Now only 2 elements are left, 5 and 64. With the size function, display the size of queue. Now size of queue is 2. And finally call the display function. Display function display the total number of elements present in the queue. Now only 2 elements are left. The output is 5 and 64. Now run this code. After the execution of this code, the output is initially the queue is empty. After that, 1 was inserted into the queue. Then 28 inserted into the queue. Then 5 inserted into the queue. Then 64 inserted into the queue. And the size of queue is 4. The element in the front of Q is 1 and size of Q is 4. After that, print the element of the Q. Element of Q are 1, 28, 5 and 64. Then popped element 1. Then after that, popped element 28. Then size of Q is 2. Only 2 elements are there. And then printing the elements of the Q. The output is 5 and 64. This is all about the array representation of a Q.